Hey guys, bonus video. A couple of you have been asking me about numbers 27 and numbers 30 on the homework for section 6.4. I don't know if the key is already up, but if it's not, it will be up as soon as I finish this video. But this is an important skill that we need to know, and so I want to practice it a little bit more. I know in my lecture on Friday we didn't really talk about going from rectangular to polar coordinates and then listing all of the polar coordinates that satisfy certain domains. And so that's what 27 and 30 on your homework asked you to do. And so I thought it'd be helpful to do 28 and 29 to kind of talk through those and show you what I think as I do it. You can watch this video, you can ignore this video, you can practice these problems and then come back and check what your answers are. It really doesn't matter to me, but I just think that this would be helpful. It's an important skill and I want you to know how to do it. So that being said, we're going to get into number 28, and it says we're looking at the point P equals 1, 3. And it says that this is rectangular coordinates of point P are given. Find all polar coordinates that satisfy it. So we're going from rectangular to polar. Okay, so that being said, we got to figure out if I have x and y, we got to find what r and theta are. So I'm going to do this first, and this should be what you guys already know. R squared is equal to x squared plus y squared, so it's equal to 1 squared plus 3 squared. So I'm going to solve that. R squared equals 1 plus 9. R is going to equal radical 10. All right, then I'm going to find out what theta is. I'm going to go automatically and write theta equals inverse tangent of, and then I'm going to write y over x. Because I'm going to skip the step of having tangent on the other side, I don't want to start with tangent over here because I'm going to eventually have to get it to the right-hand side. So I just started it where I wanted it. Now that it's here, I'm just going to throw in my calculator second tan of 3 divided by 1, or just 3. Make sure that you're in the degree mode so that you get a degree out. Inverse tangent of 3 is 71.6. So theta equals 71.6 degrees. All right, before we do anything, we're going to check. I have a positive r and I have a theta that's between 0 and 90, which means that it's somewhere in the first quadrant. So it's somewhere in this area, and 1, 3 is also somewhere in this area. So this point is good as it is. Root 10, 71.6 degrees. Okay, this is the base point. What parts A, B, and C of the same question ask is just other ways to write this polar coordinate. Everything that we write is this exact same point, just in a different way. So I'm going to move to the next slide, and I'm going to write my answer, root 10, 71.6 at the top. We're going to kind of use this as our base. Before we do anything, I'm going to draw this really quick. If I do root 10, 71.6, so the line of 71 is like somewhere over here. It's like close to 90, but it's not quite 90. It's more than 60, it's more than 45. It's somewhere right around here is our 71.6 degrees. If I go from my positive x-axis to there, that's 71.6. And then we can just say that my length from here and the origin is root 10. We're just estimating. It's not exact, we're just estimating. This is helpful, I think, because from here we're able to kind of see what other angles we look like from this area. So I'm going to start with, we're looking in the domain of 0 to 2 pi. And remember that 2 pi is the same thing as 360. So if you need to write that to help you out, go for it. So first thing, my original angle already works in here, or my original point already works in here. We already said that it works in the first quadrant, so it satisfies everything between 0 to 260. Oh, 360, that was weird, I don't know why I said that. From 0 to 360. Now, one way that we learned in class on Friday was to write another polar coordinate by doing the same angle plus 360, so we could do all the way around 360 plus 71.6, but if we went all the way around and plus 71, that would be bigger than my 360, so that doesn't fit in my domain, so that's no longer an option. Instead, what I'm going to do is I'm going to put this line back. I don't know why it went away. Another option I said is that we could add 180 to the existing angle that we have and just make our R, my distance, negative. So I'm looking at this angle, but I'm going to go backwards. I'm going to go negative the other way. So I'm going to go up this direction essentially with my distance instead of down towards it. So if I add 180 to 71.6, 71.6 plus 180 is 251.6. So then that means, I'm just going to try and use some different colors, that from here to here is 251.6. And so that's another one of my points, is this negative root 10, and then I'm going to write 251.6. Both of these angles are between 0 and 360, so that's good. Okay. Now I'm going to do the domain that goes negative pi to pi, or essentially negative 180 to positive 180. Okay. My first point still works. My root 10, comma 71.6 still works because it's still somewhere between negative 180 and positive 180. This still is fine. Now, I can have negative angles here. So we're going to keep our lines kind of the same as we have right now, but instead of doing positive 251, we are going to go the opposite way. So what if I had gone this way to the exact same angle? I can still have my negative root 10, and it's the exact same angle as my 251, but it's going the opposite way. So it's like if I did, let's see, you can think of it as 360 minus this, or this number minus 360, so you get a negative angle, or you can do 180 subtracted from this 71.6. Either way works. It's the same math, gets you the same place. And then that number is going to be, so if I do 71.6 minus 180, then that gives me negative 108.4 degrees. Okay, so again, I used the same angle, and this time I did negative r, and I did minus 180 from my theta. So that's how I got to this angle right here. All right, then the last domain, or last, I guess, piece that it gives us is that we're going to go from 0 to 4 pi. Okay, well, that already uses everything that we just said in example 1. Like, all of these are still true because they go from 0 to 2 pi. So if I now go 0 to 4 pi, all of those points are the same. So I'm going to write same as part A, and then I'm going to have two other angles. Now, since I'm going to be bigger than my 2 pi, bigger than what I'm used to, I'm going to go all the way around and then to my original angle. So I'm going to now do that 360 plus my angle. I told you we couldn't do that before, but that's because I had to have my numbers less than 360. Now they just have to be less than 4 pi, which is much bigger than that, so I'm allowed to do that. So one point that works is root 10, and then 71.6 plus 360, which is 431.6 degrees. So that works. And then I can also do 360 plus the other angle that we had, this one right here. That was in my first set as well with my negative root 10. I can do that and do 360 plus that. So there's going to be a lot of lines on here, but just deal with me for a second. I'm going to go all the way around and then all the way to this angle right here. So that's 360 plus that 251. And that gives me 611.6. So negative root 10 and then 611.6 degrees. Okay? I'm going to do one more. So I'm going to go write that problem down, and then I want you to pause this and check and maybe try both of these on your own. So this next one, the last one that I'm going to do with you, says, it's number 29 in your book, so if you want to check there, it says P equals negative 2, 5. So pause, try that on your own. All right, welcome back, or thanks for sticking with me. Let's do this one. I'm going to, as always, find my P, my R, and my theta first. So this is my X, and that's my Y. R squared equals negative 2 squared plus 5 squared. R squared equals 4 plus 25, so that makes R equal to root 29. Okay, now I'm going to do theta. Theta equals inverse tangent of 5 over negative 2. So I'm going to do second tan 5 divided by negative 2, and I get negative 68.2. Okay, before we do anything else, we need to see, is this legit? I have negative 68.2. Where is this original graph? Where's that point going to be? If I were to graph that point, negative 2, 5 would be negative 2, and then up 5, it'd be somewhere like here. Is negative 68.2 in that second quadrant? Well, the answer is no. We have to figure out what angle is in that second quadrant. Essentially, I'm looking at like this line right here. This distance is at negative 68.2, so we got to figure out what this distance is. To do that, you can just do 180 plus this negative 68.2. That's going to give me 111.8. And so that's actually the theta that I'm going to use, 111.8. So my like normal point is this root 29, 111.8. Again, we had to do that because we're not in the fourth quadrant, we're in the second quadrant, quadrant 2. And so I need this point to match that fact up there. Okay, now we're going to go do our constraints, our restrictions, whatever you want to call them. So I've got A is 0 to 2 pi. I'm going to write B is negative pi to pi, and then C is 0 to 4 pi. And I'm going to draw my little graph over here again. We'll say this is the line. There's my point. We know that this is root 29. We know this is 111.8 is that distance right here. We know that that's the point I'm going to start with, root 29, 111.8 degrees. In order to find the other angle that this works with, that is between 0 and 2 pi or 360, we're going to go to this angle down here, and then we're going to have a negative 29. So you can think of that as 180 plus your 111.8, and then a negative root 29. Negative root 29, and then 180 plus 111.8, which is 291.8. Oh, I forgot my radical. And again, what we did here, negative r, add 180 to my theta. Okay, now if I want to do my negative angles, my original one still stands. It still counts in this area. It's between positive 180 and negative 180. Essentially, if you go from negative 180 to positive 180, that's the general space that you're going in, and what we have fits in that space, so that's fine. So I'm going to do my normal root 29, 111.8. Okay. Now I'm going to go and do the negative angle. The good thing is we just found the negative angle a minute ago. It was given to us by the calculator. So if I go this way to find the angle, we've already used this angle line before. We called it 225 earlier, or sorry, 251.8 earlier. Now I'm going to go in the opposite direction, and we know that that's negative 68.2. If we didn't remember that, you can do 111.8 minus 180, and then that should also give you the same answer. So this new point is negative root 29, negative 68.2 degrees. All right, and then now we're on to our last one. So the first thing that I have to remember is, since this goes from 0 to 4 pi, we have the same answers as part A, because that goes 0 to 2 pi, so I have to use that here as well. We also have two new points. Now is where we get to add 360 to our original points. So I'm taking my original 2 points and adding 360 to them. My original 2, adding 360. So I'm going to go around and then to that 111. So 360 plus 111.8 is 471.8. So root 29, 471.8. And then I'm going to take my other angle from my original group, that 291.8, and add 180 or 360 to that as well. So again, I'm going to go all the way around, and then I'm going to go around back to this line. We've touched it every single time. Now it's just 360 plus that 251.8. And I get 611.8. Remember, it's a negative root 29 now, positive 611.8. Okay, I hope that cleared up a couple things. If you have any other questions on these, let me know. Bye.